make my own. That'll fix all those knots in your hair.
Oh, send it to me.
Wait. Well, hang on. Does it contain urine?
No,
Okay.
No, I do not use urine in any sort of therapy.
Okay, as long as it doesn't have urine in it, I might give it a shot. Okay, because I just not into that urine tonic.
That's my first thought.
Yeah, you got to ask with a flat earther, right? You never know. So,
see, there's a question that I want to ask Ross before while we're still waiting on Red. So go ahead and start. And
we're live.
Oh, we are now
talking about urine. Yeah,
I'm literally eating my my cinnamon toast crunch. You gave me no warning.
I said I was going live.
Oh, this is just too beautiful.
Listen, I have to eat sometime. I've been on stream since 7 o'clock. Okay, I am human. I'm hungry, and I have a ritual at the end of every stream. I always have cinnamon toast crunch. It's just a thing I do. Which, by the way, we got a huge increase today in subscribers. So first of all, thank you, and we are so close to that 20K by Christmas. So I think it actually might happen. And you guys are
How many do we need?
It depends on where you go. I've stopped until all of them are at 20K. All the places that you can go to see how many subscribers.
Approximately 200, maybe a little less, but
yeah,
but 200 would definitely do it. So
roughly.
That's about how many I've got.
Well, send them over. Jim, before we go any further, Jim, can you just kind of do that thing again?
Oh, with the hair?
Yeah, just do that. Jim, you're creating dead air. All eyes are on you.
I'm so confused about this.
I was listening to the petty officer. I didn't know who we were talking to.
Oh yeah, you did this like thing.
Does he outrank you, Jim? Were you not an E5?
See, that's perfect. That's perfect.
I got out as E5.
I got out as an E6. So
you know what's funny? I wasn't going to tell this story, but I'm going to tell it now anyway. Since I'm already embarrassed with me coming on eating cereal. There's this really nice restaurant that is new near where I live, and during the last show, I ordered. They have these. I'm a huge fan of fried pickles. Like I love fried pickles, and they have like the best fried pickles with this horseradish sauce. It's to die for. So I ordered some while we were in the last show, so they would get here and I could go grab them and come and hopefully eat them before this show started. So they arrived. We closed out of the last show. I went to the door, and just a little thing about me. When I'm not joking when I say I don't wear pants whenever I'm doing the show, because you only see from the from the top up. So in the rush of me hearing the doorbell ring and coming off the show, I don't think about this predicament that I'm in. Now, granted, I have boxer briefs on or whatever, but here I am in a shirt and tie and a jacket with boxers on. And if you could have seen the look on the guy's face when I opened the door, it was priceless. But I didn't have time to give a fuck. I really didn't. I was just like, oh, thank you. Here's your tip. Gotta go. But it hit me afterwards when I was walking to the refrigerator. I was like, he's probably going to think I'm some weirdo. I am I'm some strange.
Most people do.
Think or no?
That's okay. All right, what was your question you want to lead out with so we can dive into this?
So Ross, I wasn't here when you were here the first time, and I heard little fragments about something to do with the moon, and I would rather just hear it from you in your theory about something with the Grand Canyon and the moon. Okay,
so that's just a best theory. It's a best guess theory. I'm not saying this is a concrete rule, but when you look at the really good video, I thought it was called "There Are No Forests on the Flat Earth." It's done by a Russian guy, and it's a very mind-expanding video that shows a potential history of the Earth that we've never even considered before. And when you start looking at all the evidence, it starts to really look like, wow, this guy's really onto something. He's actually blown my mind here, showing evidence that the mountains and so on are actually remnants of what were once living trees. And that it's also made me think that maybe the entire Earth might have all been living creatures, maybe even giants or whatever. But the Grand Canyon itself looks exactly like the sort of thing we would do on a much bigger scale doing a strip mine. And so I just sort of put two and two together and thought, well, if the giants put the moon up there, they would have had to get the raw materials from somewhere. So I'm suggesting it's something like some sort of maybe obsidian or glass or something. So they've melted down all this stuff in quite a bit of a hurry because they want to put this thing up there, and you could easily make hydrogen with some sort of electrolysis sort of thing out of water. So to me, it just seems like it could well be, my best guess for what the moon actually is. It's either hydrogen or helium-filled giant big bauble. And then obviously what the craters are was the effect of when the glass was cooling, a bit like, you know, liquid mud popping in bubbles or something, is that's what actually created what we see as craters. Because I don't think there's ever been any evidence in the last few hundred years where we've had great telescopes and all this sort of stuff of showing any sort of evidence of the moon's craters ever changing. I don't think that they're out of space or anything. And so that's why I think there's another explanation for it, and that is the rapid cooling of something that they made in a hurry.
You know what's interesting? That's actually not the strangest thing that I have heard on this show. So I'm not sure how to react.
I think that was from a parody video.
Well, I was about to ask you, Russ, is you are aware that the creators of that video came out and admitted that they were just trolling the conspiracy communities with that, right?
Right.
Just like a few months ago, actually, it was back on April 1st, the whole Beelu thing. Both of them, same thing, admitted cons.
Yeah.
You're citing your source as an admitted con artist, as an admitted lying source.
But Jared, listen to this.
Foundation.
But Jared, listen to this. We actually had a gentleman on here who is a PhD say that fossils are on the moon because of impacts with.
Well, that's not, that actually isn't far-fetched, because he's talking about
yes, it is.
Hang on. He's talking about very old, billions of years old fossils from impacts from the Earth, which is actually feasible. They think there might be fossils on the moon and possibly even Mars from possibility from impact from ejected. But that's a whole different ballgame. But not like you're going to find a whale fossil on the moon like Nephilim.
You're letting your bias get in the way, I think.
In Australian Aboriginal mythology, they talk about a time when there wasn't a moon. And so we're talking about a culture that's been here for potentially over 100,000 years. So if anybody would know, it's the Australian Aborigines. And there are evidence of other cultures also talking about a time when there was no moon. So I just think it's a possibility that it had to get there from somehow, somewhere. One of the earliest theories I heard years ago was that it was dragged from another part of outer space by aliens. And I no longer buy into the whole alien theory at all.
Well, hang on. Let me quote this from you, because you said I was wrong and I had bias. This is from New Scientist. Okay, New Scientist is a very well-known.
Sure, go ahead.
Ancient Earth fossils could be found on the moon. And they're quoting what was the same thing for the Mars rock, which was the ALH 84001, where that struck the Earth, and they were looking for fossils of that from the moon. This is completely possible.
I still think I think it's crazy. This is my opinion. I think it's crazy. But Ross, let me ask you a question about when isn't it simpler? Like, doesn't it make more sense that the moon was probably it was originally part of the Earth, and we got hit by something that casted it out. They got caught in that gravitational pull, and it just is there. Like, doesn't that make more? It's simpler, right? It's a lot simpler.
Not really, because in order for something to have buoyancy, it has to be full of lighter sort of gases. Like
not necessarily.
I explained on the interview today how the moon on the globe Earth makes zero sense because of all the different speeds it must be going at, just in order to appear to be wafting gently around us. That the simplest explanation for anything, like in the Occam's razor, says that the more simple one with the least convoluted answers says that that's most likely.
It doesn't.
It does not have convoluted in there at all whatsoever. But
yeah,
this is the question that really struck me that I wanted to bring into this, which will actually should be short enough to deal with before we even get into the physics, because we'll be honest, that will take time because it is very nuanced and very in-depth. Ross, you claimed that the Antarctica Treaty denied all entry to the continent, correct?
Not necessarily all entry. You can get permits.
We can go back, and you said it denied all transit to the continent.
It denied exploration. Yes.
Actually, no, it only limits to exploration. Can you show me in the treaty where it says that it denies exploration?
Well, it's just the process.
Better,
I think
better
when
yet,
people make a video
read
showing
the
the
treaty?
process you have to go
Have
through to
you
get
read
permission
the
to go
treaty?
there.
Yes,
Makes it very
they
possible.
want to make sure that you have insurance, because if something happens to you while you are there, it is fucking expensive, and the people who are there doing other jobs, and you have to make sure that time and recompense, if they have to come save your dumbass, is already there and covered.
Of course,
But-
and I don't think it'd be feasible to do it anyway without the right equipment, as I explained, with some sort of helium blimp running on air power.
So you are now changing from it saying you can't go there to it lays out a framework of what you need to do to appropriately go there. Is that what I'm understanding?
Let's all get along in this hangout. We're gonna do physics, and we're all gonna try to come together. Let's for once not have a confusion.
Jared and I, because Reds hasn't shown up yet. Jared and I have already talked about a few things we're going to discuss. I'll start this off by saying, hey, like Flatter Jesus, you seem like a really nice guy. I'm just telling you straight up, everything you literally have said about science and physics is not even just wrong. It's wronger than wrong, has no reality whatsoever. You'll never find in that in any studies whatsoever, because there's no possible way of what you said is correct. And some of the terminology you use is incorrect. And that's what we're going to be hopefully addressing in this after show. I took mental notes, but of course, I didn't write any things down. So I'm going to give you the simplest things first. And I think you need to be corrected on. You had mentioned something about having a tube and putting electrodes and having a current go through there and it lighting up. That is not illumination. That is called fluorescence. It's an ionized state of a gas due to electrical current, because you have a photon being released from the excited atoms. Illumination is when you have an external source of light that's being reflected off something. Do you agree? And that's not very complicated. Do you agree that those are fundamentally different things, illumination versus fluorescence?
I can say I agree what you're saying, because that's what I also used to believe. But I've come to a different understanding after watching how these people have done experiments with the neon gases and so forth. And they show that when you put it near like a coil, an enclosed tube,
it's illumination. Yes. No, so it's still fluorescence. It's not illumination.
Fluorescence.
What happens is when you have a tube, like a neon tube bulb, and you put it near a coil, a coil with an electric field, that will excite the atoms inside that gas. You don't have to have current on the ends. What you're having is a changing magnetic and electric field going across it, and you're having an excitation of the atoms. They're releasing photons. So what's happening is that gas is getting energy into that system that's allowing that photon to jump from the transition of electron orbitals. So you know how that works, right? You have an atom, you have electrons, you have a transition from one state to another. And when an electron jumps from a higher state to a lower state, that energy has to go somewhere. That is what a photon would be, right? I mean, I think you do know that much, right? Because okay.
Yeah, that makes sense. But
okay.
To me, trying to understand the way the sun works and how it appears to us, because they say, the angular size never changes and all this.
Well, we're not going to get into that yet.
What it appears to us, though, is completely different from.
Yeah, we're gonna take this progressively. I want to get one concept down at a time. Okay, so you got that concept. So it's not illumination, it's luminescence, because the excitation of the atoms inside the neon tube, or whatever the gas is, because it could be sodium, it could be neon, whatever. Each one's gonna have a little different color. All right. So Jared, why don't you bring up your diagram here, and you can start off, and then I can kind of address a little bit as well.
All right, let me find the way to get it showing again, because Zoom does not like the screen share feature. This is why we should use Meets.
You know what? I got to tell you, Zoom is really easy to use. I think it has great sound, great video, great audio. I've been very happy with Zoom, to be honest with you. And you can get online so much easier without having to go through OBS or XSplit.
Somebody just got $50 from Zoom.
Hey,
I'll sponsor them.
Got to keep the lights on.
Yeah, for sure. There's plenty around here with no lights at all.
Well, if you can't, I don't know I don't know how we're going to show this.
Well,
Well, I just mentioned something.
once
while
I
you're
get
doing it.
this set, let me.
I might just mention something quickly,
Sure.
Steve, while you're working this out. Is the sunlight is lighting outside with direct light, but the room in here is illuminated by indirect sunlight. That is why I sort of say that it's the atmosphere itself which is glowing in the presence of.
Well, no, the atmosphere doesn't.
sunlight.
The atmosphere doesn't glow. Okay, and the atmosphere is translucent. What's
Well,
happening
how do
is
you get sunlight in
because you have light is reflected off surfaces, right? And so when you have a reflective surface, this is like the moon, it has a beetle of 0.8 or something. I don't remember the exact number, but as the sunlight hits it, some of that's going to get absorbed, some of it's going to be bounced off of that, right? And usually if you have a lighter surface like white, you're going to have more photons being bounced off, right? That's why if you have a black body, all the energy that's going into it gets absorbed, right? You don't have any reflection back. That's why you have what's called black body radiation. You can look at these temperatures and see what the temperature is for a black body, because at a certain theoretical point, all energy, all photons that are hitting that surface are being absorbed by the surface. And I'm hoping I'm getting a lot of this right. I had no time to prepare for any of this, and I haven't looked at any of this stuff in ages. So if you're a physicist in the live chat, check my shit. So, but anyways, Jared, because he was talking about how rockets don't work in space. I think once and for all, my goal is to have a flat earther understand why rockets will work in space.
Okay.
Okay, let's try this, man.
All right. So Roscoe, you can see what I am sharing as video right now, correct?
Yep.
So I've color coded it beautifully because this is the simplified display of how a rocket engine works.
Can you reverse it, or is that possible, or is that just?
It looks fine on my end.
No, it's. I can look on the outside. It's
Yeah,
actually.
it's back to front, but I can understand it.
All right. So it needs to flip that way.
There we go.
See, that's the thing. Magic Camera shows it one way, the internal shows it another, and yeah, gotta love technology sometimes. See, and that's the thing, is they still fuck shit up. It's not like everything technology wise is perfect.
Hey, real quick before you do that, hey Ross, did that whole atmosphere thing? Did you watch a video by Orphan Red on that in order to get that? Okay.
No, I'm not sure who did the video initially. It's a guy who builds vacuum chambers
All right, just
and
curious.
rocket experiments within
Right.
it. And I can tell you right now why it won't work. Because the rocket itself is the physical body. The gases are what's coming out at mass propulsion. So what's going to be coming out is the mass propulsion pushing the body.
Ross, I don't want to spend forever on doing this. You've already explained to us why you think it doesn't work. We're here to explain to you why it does. I'm honestly not interested in why you think it doesn't work, because you're wrong. We're going to explain to you this. You can accept it or you don't.
But I've seen the experiments done.
We're going to explain to you the science. That's that. So let your mind open up a little bit here. Jared, go for it. And then, like I said, I want to tag on this.
So the simple segments that you have here in blue, you have the LOX, which is your liquid oxygen, your oxidizer. The yellow is your kerosene or rocket propellant grade 1, as most rockets use. It's a liquid fuel. The red section you see would be the ignition portion. So when you mix the appropriate ratio of kerosene to LOX and then ignite it, you get combustion. That combustion is shown in orange. Now, this active combustion is the thermal reaction that results in hyperexpansion. That hyperexpansion and that release of an energetic state creates a force. That force is contained in that box where the orange is, which is known as the combustion chamber. There is only one avenue of escape for those expanding gases from the combustion chamber while the engine is running, and that is out the exhaust housing. So what that ends up giving you is an imbalance of the force inside the combustion chamber, where you have the forces hitting the sides of the combustion chamber, but you have a lack of force where the exhaust housing is, where the exhaust nozzle is. So what happens when you have an unbalanced force? Well, you get motion in the opposite direction. Think about when you have a balloon and you blow it up and you're holding the neck closed and it's containing the air that you just blew into it, and then you let go. all that air you pushed in there is now forcing its way back out that neck of the balloon, and the balloon flies in a direction opposite of where that goes.
Hang on, Ross. Hang on. Okay, so
that balloon will do that whether there is an atmosphere around the balloon or not.
right, even in space, it will do that. And Ross, I want you to think about this. Hang on, I want you to answer my questions here if you can, because I'm here to help you. I'm not interested in you teaching anything. You don't know about this topic, okay? So we're here to help you, because because honestly, and be honest with me. Have you ever taken a physics course in college?
Oh, I've done some physics in high school. Yes.
No, college.
Well, our high school is above your college level. Actually, I spent a year in the States when I was 16 as an exchange student. Have you taken your
mathematics?
education standards in the US are so low, it's not funny. I was doing stuff.
Okay, but have you taken mathematics?
11, but I was doing in year 9.
Have you taken mathematics?
Yeah.
Okay. All right. So
maths, physics, engineering, science.
All right. So are you familiar with Pascal's pressure law?
I've heard of it.
Okay, you've heard of it. Pascal's not only have I heard of it, I can quote you it verbatim, and I'm not even looking. So just like pi, the pressure exerted on an enclosed fluid at rest will be transmitted equally undiminished throughout the fluid into the walls of its container. I have had that memorized for 20 plus years. Okay. What that means is something very simple, and I want you to understand the concept. I'm not trying to do this. Oh, Steve's smart shit. I am smart on this, but that doesn't matter. Okay. I want you to actually understand the concept. So think about this. If I had a ball, like a basketball, and it's at some kind of pressure, as 14 psi or something at 20 psi, whatever the hell basketball is at. I know tires like 40 some odd psi, but whatever the psi is for the basketball, would you agree that because it's encapsulated, because it is an enclosed fluid at rest, because gas is a fluid, that all forces are equally distributed throughout the inside of that basketball? Would you agree with that?
Yeah, give or take a weak point. Yeah.
Okay, so is that equilibrium? Okay, as Jared was saying, that's a brilliant way to put it. It is an equilibrium conditions. That basketball can sit on a table; it's not going anywhere ever, right? Because of the pressure that's inside. As soon as you poke a hole in a large size hole in that balloon, let's use a balloon because balloons move much easier. So if you have a balloon, it's equally the forces are equally distributed on the inside of that balloon. But when you poke a hole, and let's say you have like tape over so it doesn't explode, now you're no longer at equilibrium conditions. The air inside there is being ejected through that hole. It is going somewhere. Okay, it's going out, but it's not pushing against anything any longer, right? It's a lack of a wall there, a boundary condition they call it.
Yeah.
But you still have what's called the linear conservation the conservation of linear momentum, which means that the force on the other side is going to be pushing on that part of the balloon. Okay, so you have all these masses going out of the balloon going this way. So in order to have an equal set and opposite reaction, Newton's law of motion, what do you think direction of the balloon is going to go?
Well, yes, that works in air. But what I'm trying to say to you is if a rocket is in a vacuum, what's happening is the propulsion is going to get forced at massive speeds without pushing against the rocket. It's just going to go and fill the void.
Okay. Right.
Flat of Jesus. Listen very carefully. Let me finish, and then I'll throw it over to you. Trust me. Listen very carefully. In what I told you,
told me, yes, but it's in air.
Did I ever tell you the conditions outside the boundary?
You said on the table, yeah. Okay,
but could that table be in space? I never told you the outside conditions. You just naturally assume them. The outside conditions. The outside conditions make no difference to the math nor the physics. You can prove this by putting the balloon in a vacuum chamber, and it'll do the exact same thing every single time. Oh, okay. Hang on, Jim. You want to go?
Have you shown that?
You can do your own experiment on it. Get a belt chamber, suck the air out of it, put it in a vacuum, put something in it.
Looked at multiple vacuum chamber experiments, and I know that without any sort of density in there, nothing can thrust off it. The flies can't fly. The balloon just explodes.
So if I was able to find a video of,
with great force.
If I was able to find a video in less than 5 minutes that shows a force from a rocket being ignited in a vacuum, will you drop this argument?
I will explain why it does it because
no. You're not going to hang on, Ross. This is what drives me nuts. You're not going to explain it. you don't understand because you're not going to explain it. We're explaining it to you. Either you accept it or you don't, but it doesn't change reality, man. That's what I think. Answer me this, Ross.
Well, I can find the video for you.
Wait, would you agree that I have a nominal amount of education in this? Not exceptional.
Absolutely. Yeah.
Jared has a nominal amount, probably even more than I do in some regards, because he's been doing this a lot longer. Why won't you listen to the people that are trying to explain it to you properly? Take it to your, on board and go, maybe these people that have researched this and looked into it have something that makes sense. And you can do these experiments. Red has done these experiments. You can as well do them on your own time. I'm
not trying to disagree with you necessarily. I'm just telling you why it won't work, because I have done the investigations myself, and I've seen that when there's in a vacuum, the gases want to take the path of least resistance and they rush to fill the void, but they don't actually push the rocket. The only amount of push it gets is when it hits maybe the back of the chamber and it gives it a slight little shove, but it all rushes out at way faster.
Right. Hang on. So if I can find a video in less than 5 minutes that shows a force being produced prior to the exhaust building up on the back end of the vacuum chamber, will you drop that argument?
Inside a vacuum chamber?
Yes.
Okay, I will.
Will you will drop that argument?
Okay.
All right, I'll be back in about 5 minutes or less.
That's a start. I mean, got to start somewhere, right? But okay, go ahead.
There's a channel called Action Labs, and they do vacuum chamber experiments all the time. And they did one where they put a Coke can inside a vacuum chamber, hanging on a bit of string, and then they had it so they pierced the Coke can, and they had it in slow motion. And inside the vacuum, when the liquid started exiting the Coke can moved before that liquid touched the edge of the vacuum chamber, showing that there was no medium required for the thrust to be created. So how would you explain that, Roscoe?
Right.
I have a question. How long has it been? Has it been less than 5 minutes?
Yeah.
Yeah. Oh, yeah. Considerably.
Because right there, I just put it in the internal chat here of Zoom. And do you want to go? And for the public, I am putting it into the live chat as well.
You want to go check it out? Because I don't know how you can even play a video.
If it's the one I'm thinking of, it's about 10 or 15 minutes. It's a bit lengthy.
So it's over 15 minutes long. It shows you the complete setup that they use. They even walk you through. If you want a shorter one,
it's called Rockets in a Vacuum Chamber, Newton's third law of motion visualized, which I told you, laws of motion, by warp perception. But again,
they have a shorter 5.5 minute one where they do it in a different setup that shows the same thing. They measure a force from the rocket engine igniting prior to the gases building up on the back end of the vacuum chamber.
See, but all Flat Earth Jesus has to do is say that these people didn't know how to do an experiment. But my response to you would be, Flat Earth Jesus, until you can show us your math is better than their math.
Well, but they showed on their experiment how they did it. They put the rocket on like a sliding scale so it wouldn't move out of the wrong direction, and it barely moved at all. All the rocket propellant just came out super fast because it wanted to fill the void of the vacuum.
They were using a model. They were using a model rocket engine, and it still measured a force upon ignition in both videos.
It's proof of concept. There's proof there that you don't need the medium to be able to create thrust. So it proves that rockets can work in space.
Yeah, if anything,
whether it moves a little bit or not isn't the point. The fact is that it moved.
I wish Rez was here, but Rez did get called in for something other, so he's not gonna be able to make it. But I wish he was here because this is where he would shine on what's called the rocket equations. Because when you have an atmosphere, correct me if I'm wrong, Jared, but it'll produce a back pressure.
Yes, when you have
that has an effect on that.
When you have an atmosphere, it creates a back pressure, which there are some instances, some build qualities and build variants of rocket engines that require back pressure to get the ignition going. Also, you have to take the atmosphere into account when you are going through the atmosphere because of this pesky thing called drag. You want to make sure that you are aerodynamically sound to go through the trajectory and go in a controlled manner that you want to. Basic fundamentals of flight.
Yeah, and they tend to increase efficiency as they lessen the amount of fuel, because the biggest part of a rocket's problem to get into space is that fuel's heavy, right? And so you need a lot of fuel in order to do that. Now we're gonna Jared and I are going to address that a little bit through Roscoe, because you said something that really kind of really made me take pause. You said that people can't use equations or can't figure out how to do this, how to put something in space, which is absurdly wrong. And the reason I say that is, are you familiar with kinematics?
Kinematics.
Study of projectile motion. Okay, in a parabolic equation, and again, I know I'm speaking above your head. I get that. It's for the audience. I will dumb it down. But
I know what a parabolic equation is.
But when you have a change of of y, it's equal to, I hope I get this right, at plus 1/2 a times t squared, where a is the force or acceleration under gravity. But what that basically means is you can take this formula, okay, and I can say, hey, if I have an initial velocity, the projectile is going to go so far. Okay. So again, keeping it very simple, I shoot a gun, that projectile is going to go out at some linear X, right? You know what X and Y is, right?
Yeah.
Okay. Using cosine and sine, you can factor those out. But if I have a projectile going this way, it's going to actually fall toward the earth. You do agree with that, would you not?
Yeah.
Okay. That you can model using these parabolic equations, even though it's technically an ellipse. But now, the more energy I put into that system, the further that's going to go before it hits the ground. Would you agree?
Yeah, because it's beating the air resistance.
Okay. Yeah. And you normally you should say that these things are negligible air resistance, but yes, air resistance does have drag, as Jared noted. But once you get enough energy in that system, you reach what's called orbital velocity. Okay. But when they talk about rockets, you'll hear something called delta V. And delta V is not change of velocity like you normally would think delta V. If I remember correctly, delta V has to do with how much impulse you have, which is basically your force over your time. But it's how much energy you're going, how many meters per second in order to get in space. And I don't remember what it was.
It's the benchmark to reach the orbit that you want.
Yeah, what is it? 7,000, 8,000, 9,000 kilometers per second? I don't remember what it was.
A little over 7,000 for initial orbiting, which is generally in the low Earth orbit range.
Okay, sounds about right. 7 to 9,000, I would say too. So low Earth orbit is 99 miles above the Earth. It's anywhere between 99 and 1,200, right? So if I get enough energy in that system, it's going to keep going, and it's going to keep falling, right? If I give it a certain amount of energy and it goes this far, more energy is going to go this far, and more energy is going to go that far. Eventually, it's going to keep going until it's going to low Earth orbit, because it's actually falling around the Earth. It's called Newton's canon.
Okay. So can I ask you a question about that one then? So if the Earth itself, as we were discussing previously, is going 67,000 miles per hour through the galaxy on its daily orbital spin, then once it's falling, doesn't the law of inertia say it will just keep on falling and not get somehow magically sucked back in because of this?
No,
because the law of inertia says it's already moving at that rate.
Think about this very carefully. When I fire that bullet is with respect to the ground. Okay, so how much movement am I having right now with respect to the ground? What's my displacement? None.
Yeah, zero. But we're talking about a rocket, not a bullet.
Okay, but same principle. If we're moving through space, then I'm moving through space at the same velocity that the Earth is. So that rocket has energy imparted in that already from the movement of the Earth. This is why sometimes not sometimes anymore, they'll always launch from one direction specifically, because it helps the rocket get into orbit. Because an orbit a rocket does not go straight up. Okay. A rocket will go, and it's always going to go in this kind of thing, because it enters into an orbit, right? And it's much more energy efficient to do that than send something straight up.
But how does it then re-accelerate for that 67,000 mile per hour of the Earth moving away if it's going that way? Is the inertia isn't dragging it with it as it goes?
Yes. The inertia you begin with is the inertia you maintain until you apply an opposing force to negate it. Now, this is where the analogy that Red started to go with of the platform around the car comes into play, because you are not going to negate the initial inertia that you have applied to you when you are lifting off from Earth until you leave Earth's gravity well. Once you leave the influence of Earth's gravity well, then you are off the platform. Then you start
that pretty fast, though, wouldn't you? If the Earth itself is moving at this 67,000 miles an hour, the rocket's not going.
No, keep in mind, speed or velocity is always in relation to something else, is always in relation to a reference point.
It's displacement.
So when we're talking 17,000 miles per hour for a rocket to get up to maintain low Earth orbit, that is in relation to a single point on the surface of the Earth.
Exactly.
If the Earth is moving in a direction, your reference point is moving in that direction. You don't add that speed because that speed is your zero reference point.
Yeah, it factors out in the equations. If you ever did do these parametric equations or elliptical equations, all this stuff that you're talking about factors out. This is why I'm really hesitant to say that you've had any experience in this, because anybody who's done a feed body diagram or anybody's worked with kinetics has seen this, how this works mathematically. It's elegant, to say the least, how parametric equations work.
If you jump off a moving, speeding train, you do not keep that inertial speed when you go flying off.
You will if there's no
yes.
wind resistance.
Hang on. Yes. You retain it, but then the wind resistance. No.
Right.
Actually, it depends on how buoyant you are.
Yeah.
Think about this. If I'm in a sealed container on a train, okay, and I'm going 100 miles, okay, and it's sealed, and I'm going 100 miles an hour, and I jump up, I will land in the exact same spot that I jumped up from every single time, because there's no wind resistance. As soon as you have take the enclosure off, now when I jump up, now I have wind resistance hitting me. Now I'm going to be pushed back. But without that wind resistance, where I jump up from is where I'm going to land.
But the train is apparently going a fraction of the speed of what you suggest the Earth is going in the heliocentric.
It's all makes no. It could be going 1,000 miles an hour, or it could be going 10,000 miles an hour. It makes no difference. Zero.
Well, that's not true, because you just said that resistance gives you something.
Why is it if I'm going? Wait. Why is it if I'm going 100 miles an hour and I can jump up and I land in the same spot, nothing changes?
Well, have you tried it from like a really high?
Hang on, let me finish. What magical speed do you have to hit before that's no longer in effect?
Are you saying it arbitrarily just cuts off at the point where inertia is a force? Like, are you saying that once it gets to a certain speed, that the laws of motion just don't apply anymore? Right.
That's what I'm curious. At what speed does that no longer happen, where I jump up and I hit the ground where?
I would think if the ground was actually moving 67,000 miles per hour, then you're also adding that 100 miles to that for the train. So you've got to take both of those speeds into consideration, which the rocket also has to take into consideration. In order to be able to
this is where I got to stop you and say you're not listening. You, honest to God, are not listening. So I want you to focus on what I'm saying and not go back to rockets. Okay. I want you to conceptualize this. This is what I do. Hang on, Jim. I'll get to you. I promise. This is why I think concepts are important. Flat earthers do not have these concepts. If I'm in that train and it's enclosed, you already agreed that if I jump up, I'm going to land in the same spot. My question to you is, and can you show us at what speed does that no longer happen?
Well, as I tried to ask you, I think that your tiny little 1 or 2 foot jump isn't significant enough. But if you actually had, say, a train that had a 40-foot high ceiling and you dropped something from the top of it, I think you would find it would hit the back of the train.
It doesn't, though.
But have you tried it? Because we don't have trains.
They've done experiments. Do you think it was that easy that somebody wouldn't have done this already and won a Nobel Prize for it?
But they don't have things that tall to test it. That are
okay.
Really?
Listen, what would be why would the height matter?
Hang on, let me take another 30 seconds and find yet another video showing you're wrong.
Yeah, I mean, I gotta ask you, Ross. Are you just willfully trying to throw shit out there and see what sticks? Because
no, I like to test everything.
But you're so fundamentally flawed in your understanding of these things. Go ahead, Jim.
But I don't think you're giving it enough
to accept any
parameters to actually test it in reality.
Let Jim go.
I drove up to OKC and I flew into Providence, Rhode Island. I'm assuming that the jet was moving somewhere around 500, 600 miles per hour. And I'm laying there back in the seat, bored as hell, because I've got 2 people snoring on each side of me. And I'm just sitting there with my little pretzel bag and I'm just tossing it up and catching it. Why isn't it moving past me? I'm going 500 miles an hour. Oh, and there's a fly in there, just buzzing around.
Well, this is what I'm trying to say, that maybe if you gave it sufficient height, maybe it would actually make a difference. But in
So you
that
have no
small
evidence of that, though.
amount-
You're just pulling it out your ass, maybe.
In that small amount of space, in an enclosed space, I don't think you
Show me
can-
the physics. Go ahead.
Can
You just
can we scale down that model and actually perform this experiment?
Yeah. Why
Well,
don't you? Why
you
don't
have to
you
scale it up, because scale exists at the reality it exists at.
How
We're
do you
doing something inside a tiny enclosed cabin. It's not sufficient.
You
to-
understand? You could disprove everything we're saying by fundraising this, doing these experiments. By which way I know what happens. Flat earthers do these experiments. They realize they're wrong, and they need to figure out how to get some loophole out of it.
And well,
Or
the
they
point
just
is, though,
don't-
it's still irrelevant
or they
because
don't
we're not
release the
inside an
results at
enclosed
all.
vehicle.
Yeah.
Ross, let me ask you a question. I could do the math to prove that you are wrong. Can you do the math to prove that you are right?
Math doesn't prove anything.
Yeah.
Yes, it most certainly does. If you give me half an hour, I could do the math to prove that what you're saying is demonstrably wrong. Can you give me any kind of physics or mathematics that can prove that what you are saying is right?
No, we
Any.
need to do it at real scale, at the real.
No, I don't. I want
That's
math.
not the question. Can you do the math? Can you do the math to show us?
No,
I just-
can't
if you
do
can-
Okay, you
that.
can. So let me ask you this: if I'm designing something, right, and I'm building something, and I want to know I want to know how it works. Do you think I'm going to go to fight the flat Earth, or you for the physics?
Well, it depends what you're trying to build. I'm just trying to say that if something's
I want to.
falling,
Wait,
it's
no.
very
Okay, I want
great
to do.
inside a moving
hang on.
vehicle, you
I
would
wanna
probably
do
notice something
model
far different when thrown at 1 or 2 feet up in the air.
Listen to me. I want to do model rocketry. Not that I really do, but I mean, it would be cool. But model rocketry. And I want to understand how much fuel do I need to send a rocket so far out? I know for a fact the Flight the Flat Earth could model that for me. I guarantee it. He could go away for a half hour, 40 minutes, whatever, do the math, and I could too. Hopefully, well, maybe not anymore, but he could do it very easily. And he'll come back and say, Steve, you need to have this much fuel in your rocket to get it to go where you want. Do you have the skills to do that?
I could possibly do that. Just depends on what sort of fuel.
I don't believe you in the okay.
What size
If you could do that, give me one kinematic formula.
I don't understand the formulas. Okay, I don't really need
Well,
them.
you can't
Then
do
what
it there.
how are you going to do it if you don't understand the formulas, dude?
You need the formulas
What
to be able to
You
figure
measure
out
the
these
amount of
things.
fuel you need to go at a certain speed.
What you're saying is that you could do it as somebody else
Carry a
gives
certain payload.
the extra information, the other variables that you can't factor in. But I find it funny that you're sitting here arguing using technology that depends on the same mathematics that you're guffawing over.
Exactly.
No, I think you're just confusing reality though by putting it into formulas. Okay, formulas are useful for measuring,
Is reality.
They
Math
are
is
descriptive.
but it's not
They are
necessary to
descriptive of
explain
reality, right? We don't prescribe formulas. They describe what we observe. If you
Exactly.
can you give me one formula for anything? Again, not trying to brag here, but Jared was in the military. He had to memorize a bunch of shit. We had to memorize about 100 formulas in the military.
Oh, look, I've forgotten all
Oh,
that stuff
and
from
then my
years ago.
engineering degrees after, and
Yeah,
the
I mean,
degree I'm pursuing now.
I mean, if I said, and again, I hate pushing people on the spot, but if I asked, like Jared, what kinetic energy is, I'm pretty sure he's gonna be able to tell me. Okay, he has a degree in engineering. I mean, he's
Well, I
well learned.
right amount of speed
It's
when I'm
like-
out
it's like
body surfing.
101.
I'll
But
catch
I'm
a wave
telling you,
and be like,
It's not even 101.
but here's the thing. Okay, well, you want to go to Bernoulli's equation? You want to go?
That's on the
You want to go?
cover, right?
You
Is that
want?
on the cover?
Yeah, want to go to Stove's equations and things like that. But
I just don't think that the equations are necessary to explain the most
if
logical
you
observations
don't know
about
the
physics.
formulas, you don't understand the
Not
concepts.
to
Okay,
explain.
hang on.
Not
Hang
to
on.
explain. Formulas are necessary in order to
Mind of God got it right, by the way.
apply-
Sorry, sorry, I was so excited.
Formulas are necessary in order to apply any sort of technology to any field. Name one field that you don't need mathematics for. One single field.
Body surfing. I body surf. I catch waves
Field is that?
swimming. I use my own force and I catch a wave and I take the wave's force and I body surf. This is what I
And
do.
You know what? I could do the math.
What knowledge of how the universe works do you glean from body surfing? I mean, seriously, let's be real here. What
Well, the language of how water works in physics.
You don't know how water works. You don't know anything. You don't know anything about fluid mechanics.
What legitimate
right.
scientific field of study does not depend on mathematics?
And hang on. You know what? It's really Roscoe, it's really funny you mentioned surfing because there's a guy that I play baseball with who is an engineer like I am. He actually used the formulas to work out how to best tweak his surfboard for his body shape and style.
Cool.
Okay, so This is the second time somebody's asked this question, and I think that is a legit question. Again, I really hate sharpshooting somebody because I don't like being sharpshooted, because even though I probably will be able to get to the answers, half the time I've already checked out in half these conversations, right? So I don't know what the hell was even asked of me. But somebody asked this question, and I think it's very fair because this was asked, I think, was it Nathan Oakley? They asked this question because it's basic geometry. Do you know what equilateral triangle is?
Yeah,
Okay. All sides are equal. Would you agree?
that's correct.
Okay. So if
Same
if
angles
all
as well.
sides are, let's say, 1 inch or 2 inch or 3 inch or whatever, do you know what angles they would be inside that triangle? You know what the angles are?
What is it? Been a while. It's not 80 degrees. No.
No. Think about it this way. I want you to understand the concept. For what's called
60.
Euclid, 60. There you go. Because 180 times 3, right? So, but the fact is that is very basic geometry, right? And even when you have a right triangle, you have a 90-degree angle, so the other two angles have to be 180 minus 90 divided by 2. Anybody?
Well, you can have a 90-degree right triangle without 45,
right,
45.
Okay.
But the two other angles have to equal.
They have to be equal. They have to at least equal 90 because you have a 90-degree angle. But that is true. They don't have to be 45. I'm thinking of a of a 2 by 3 by 4. I guess it would be a right triangle. Is that what it'd be? 2 by 3 by
3, 4, 5.
3, 4, 5. Thank you very much. See that he does this all the time, right? So he's got these things that the fly. But I mean, at least he knows what a hypotenuse is, I'm guessing, right?
But the point is, well, that triangle is done on a flat piece of paper, isn't it? It only makes sense if you view it on a flat piece of paper. If you actually made a triangle out of something physical,
exactly.
The view of angles due to perspective.
Well, no, it's not perspective. It has to do with Euclidean or non-Euclidean. In non-Euclidean space, that the summation of the angles of a triangle do not have to equal 180. It could be higher or lower, depending on the positive or negative curvature. But in Euclidean space,
depends on the observer's point of view.
No, it has nothing to do with the observer's point of view.
I said if you made a physical triangle, like you got 3 pieces of timber, you made a triangle, depending on where you're viewing it, the angles are going to change.
Well,
That's,
with respect to, I kind of see what he's saying with respect to you, but it doesn't change the actual angles of the
It
triangle.
doesn't change the actual angle, but it changes how you view it. And that's pretty much what perspective is all about, is that understanding perspective doesn't change the reality of it. You've still got parallel lines, but it's just the way you view them means that they don't appear parallel when you're talking about parallel lines, not triangles.
What does parallel mean?
Well, for example, your ceiling is parallel to your floor, but when you look into the distance of your room,
But what would be a good definition?
Does it mean above and below? What does that mean?
What would be a good definition of parallel? If I wanted to tell Jim mathematically by definition, because by the way, people bitch about my definitions, but in math,
parallel means lines equal distance from each other.
And they never cross.
No, they never cross, but they can appear to cross due to distance and perspective if you've got enough distance to make it happen, which is why it's obscured.
Does it happen?
Hmm?
Have you figured that out? And how wide apart would these lines have to be, or how close would these parallel lines have to be in order to?
Well, we're talking about, say, and a good example is, say, like the Pontchartrain pylons example, is that as they go further into the distance, because of their height, they reach this obscurity point well before the tops of them are hidden further into the distance, because they're obscured by this below height, which is still parallel to them, but due to distance, it's generally, if you were standing at 6 foot of height, will be about 3 miles. That's the basic, simplest law of perspective across a flat level water distance. So
I guarantee you this, and Jared and Fight the Flat Earth can probably will validate, but I guarantee it. If you went to Lake Pontchartrain and you put to the first pylon and the very top, and you put a laser out on it, eventually that laser would diverge from the pylons.
Oh yeah,
guaranteed.
Yeah, and actually, I'll admit this. I actually used the physics of how a laser actually propagates to get out of a speeding ticket. Gotta love how I got lucky with a judge who actually understood the science and recognized that, well, this laser actually at that distance could not accurately discern if it was myself or the car that was in the lane to the left of me who was the one that was actually
Because of the
speeding.
divergence.
Yes.
Yeah, and like with that bridge, no matter how slight that curve, you have to ask yourself, like, is it my perspective, or is this just a really long ass bridge with the curve?
Yeah, and that's when you work it out, you can see that it's not curved because water doesn't curve. Water
No,
always seeks to find its level, and it's the appearance of
Ross, I've got to correct you when you keep saying that. The physics of water is not that it will always find its level. The physics of water is it will conform to whatever force is acting upon it.
Yes.
That is the physics of water.
No, not theoretically.
Absolutely.
That's not
Many
theoretically.
videos
Not in
of
reality.
water conforming to a force of sound waves on it. There is, when it's in a container, the force is the side of the container. When it's on the earth, the force is gravity. It's nothing to do with water will be level. It's water will conform to the forces acting upon it. That is the physics.
And I love Red Rhetoric's
belief, but it doesn't mean it's so.
I love Red's Rhetoric's example for this, and I'm blatantly stealing it from him because it is a brilliant example. If I have a bookshelf, right, that is perfectly parallel with the floor, that is flat and it's level. But if I tilt that at 45 degrees, it is still flat, but it is not level. You cannot use these terms synonymously. They are two very different things.
That's correct. And that's why I reminded him that you use a spirit level, which is the bubble inside an enclosed water piece with a straight edge, to find the proper level, because that's what water
Do me a
does.
favor.
What is level about a 45-degree angle? It's not level with respect to the ground.
If you put a spirit level in a centrifuge, what's it going to tell you? It will say that level is perpendicular to the surface it's on. In that case, just because
It's going to be perpendicular to the
rotation.
Yes, exactly.
Well, because you're applying another force to it. Yeah.
Exactly. It conforms to the forces that are acting on it.
Yeah.
Just like water.
That's adding an artificial force to it, not the observance of reality as we see it.
I don't know why you think
it's not an artificial force because it is a natural force, as all delineated forces are naturally occurring.
Yeah, the pseudo
we
force
just know how to manipulate it to apply those forces in different vectors.
Yeah, there are things people call artificial forces, which is a pseudo force, but mathematically and physically they still act as actual forces, but they're pseudo forces. Centrifugal force would be one of them. Centrifugal would be an actual force.
That's because you're applying the force to it. But if you left it to its own devices, it will seek and find its level, and it will be flat because that's
it will seek and find its equilibrium.
Yeah, equilibrium is the word, not level. You're totally wrong on that. Absolutely.
Well, that's why I agree to disagree, because I've done years and years.
Disagree all you want, but you have no education.
And I've seen miles and miles and miles of flat level water. Where I live here in Australia, I have some of the best views.
Let me do another
20, 30 kilometers away, and you see nothing but flat.
Yes, and I lived in the middle of the Pacific Ocean on a steel ship for many years.
You did too. Both Jim and I both did that as well.
I saw ships being obscured bottom up. I saw curvature from the top of the superstructure.
All right, so let me ask him this real quick. I just lost my chat, so let me get it back here. Sorry, guys. Do you know what a thought experiment is?
Thought experiment?
Yeah, basically, it's an experiment that you just run in your head.
Yeah, of course. Yeah.
Okay. The Germans call it a Gedanken experiment, I believe Einstein used to call it. But so, let's say you did have hypothetically a vacuum situation. Okay, so you had an isolated chamber, it could be in space or on Earth, I don't care, but you had a something that had no air into it, okay, and no gravity. It's isolated, okay, and I had a ball of water in that system. What do you think that's going to happen in this experiment?
Well, all the gases go through their natural exchange, which is the equivalent of boiling. It's just doing it at room temperature because they're trying to equalize with the pressure. Okay. Water is like a pressure gradient. So inside a vacuum, they escape and become the air because they want to fill the void.
Okay. Assuming that, and you're right, assuming it doesn't evaporate, okay, which you're absolutely right, it will do that. But assuming that it actually stays intact, okay, what shape is it going to take? What is the least resistance shape, the most lowest energy level shape that ball of water is going to take?
Well, that's a thought experiment that doesn't work in practicality. So I'd be lying to tell you that it wouldn't
These are
just escape in the
concepts.
natural gaseous stuff it's made of in the first place.
These are conceptual things. I mean, you already admitted before that the higher you go up, the more rarefied the gases are. You even said that.
Yeah, that's
Okay.
right, because that's working according to the natural observable laws of density and buoyancy.
Okay,
The only thing
so if you had a rarefied atmosphere that's more condensed in the bottom, so it's less rarefied, and the Earth was not solid, it was just all water, what shape would it be in?
Well, it's a non-question, that sort of thought experiment, because
It's not complicated, I assure you.
it would
Can
just
you not just
go flat.
answer a question once? Just
No, it
answer a
wouldn't go
direct
flat.
question.
Yeah, he's very
Flat.
evasive. It's like these are simple questions that my 13-year-old daughter would be able to understand.
Like Ross,
Flat.
do me a favor. I will give you £500 right now if you can just tell me what the word buoyancy means.
And the formula
What it
for it.
means.
And a formula that works.
Yeah.
It
And
means
the
something
actual
that gives,
definition of buoyancy.
it means something that arrests the fall of something from going further. There's a different formula
no.
for every single object. You can't just create a
Completely wrong.
unified formula
not
to say
buoyancy.
what works
You
for
cannot
every single object.
change the meaning of words to fit your narrative.
That's what he does.
What you were
Why
describing
not?
there is not buoyancy. I don't know what you're describing, but it's not buoyancy.
Yeah. So do you agree that, and again, we were in the navies, but I was in a sub. Do you agree that a submarine has a buoyant condition?
I was a submariner, so
Yeah,
Okay, he
and
was
a
submarine.
helium balloon has a buoyant condition, and a hot air balloon has a
I'm
buoyant
not-
condition.
Again, why do you keep
water has
saying
a buoyant condition? It's
Do you
different for every
agree? Do you agree that a submarine will have in equilibrium? It's going to have a buoyant factor, so it's going to stay at a certain position. I think that's kind of non-contentious, don't you?
Yeah, that's right.
Okay.
It depends on how much mass is in it and how much air is in it and how many occupants.
Sure, right. I
Lot of
can model that using a buoyant formula. Okay, and that buoyant formula does use G in it. Can you tell me how you would model it using what formula? If I want to know how, again, if I want to make it go up or down, what formula do I use?
Well, do you model that according to how deep it is in the water? Because it's going to have a lot more water pressure on top of it if it's deeper down.
Well,
and so the
that would
pressure is constantly changing.
Yeah.
You can't just create a formula to explain every different scenario.
Yeah, I can. I know the formula for it.
And it works
It has to do
as
with
well.
your fluid density. It has to do with your displacement of the water, and it has to do with which is based contingent upon your mass, right? Involve more volume, right? That's your volume.
Okay, so
water.
what's the formula?
Rho times your displacement times G. Is it rho?
Yes, rho.
I
Okay,
like to
Yeah,
understand
it's the
things
relative
in
density.
real terms.
Well, yeah, rho would be a relative density. So you have relative fluid
yeah.
density with kilograms over meters per cubic meter. So you have your volumetric displacement, which would be how much water you're moving away, because that submarine takes up a certain amount of space, right? So it moves the water. That's displacement. And then you have your standard for G 8.06 meters per second squared. So that is standard. That is a formula anybody can go use to figure out these things. You don't have a formula. The rest of the world does. This is why they go to.
But hold on a second. You've got the formula. That is the formula. That's how it works in reality because of density and buoyancy. You
It
just call
uses
it
gravity that you think doesn't even exist.
The G stands
The
for
G is gravity.
G stands for the rate of fall through the medium it's in.
Which is the
Now
gravitational
you're just making shit
acceleration.
up.
You are literally describing gravity, calling it something else. And
You're
if you
calling
say
it something else,
sounds-
exactly.
if
That's-
you
But
say
you're calling
force-
gravity the force of the attraction of mass.
No, gravity is the acceleration of something under the force of gravity. For example, if I have F equals mass equals force equals mass times acceleration, right? If I remove that acceleration, I put it gravity, I now have weight.
Yeah. But see, I don't have to reinvent that to explain the reality that you've already explained. I just don't think it's the same thing. I don't think it's called the attraction of mass. I just think it's called.
You could think it's freaking
mass
angels pushing down on a pinhead. What you
of the
think
medium it's in.
is not right. You're just taking these concepts and changing the
Well, if you
vernacular
put
to some
if you
weird.
put your submarine in thick oil, is it going to be the same formula? Yeah, it's going to change again.
Yes.
because the oil's far more
Yes,
dense.
it's the same formula. That's why it has density. You have to know. You have to know the type of fluid you're in. That's what the formula for rho is. That's your.
And that's what changes the amount of buoyancy.
Yeah, and we can model that with a formula that will tell you exactly what would happen.
Yeah,
I
rho,
could
rho is your fluid density,
Well,
right?
that's really
That's
nice,
contingent
you know?
upon
operate in a massive thing of tar.
different
I can tell
fluids. Hang on,
It's math.
different fluids are going to have different densities, right? They also have different viscosities. So the rho for the fluid is what is contingent upon the type of fluid you have. That is already built into that freaking formula.
Okay.
Any formula
So-
in this relevant fields of what we're talking about right now takes gravity into consideration. That's just a known. Like,
Yeah, but what you call gravity is what I call falling through the density of air.
You can call it fucking magic, but it doesn't change the fact that we are actually explaining to you something that's correct, and you're just making shit up.
So,
What is
so
Just
Aaron,
making a more logical explanation for why it's doing.
why is it that we can predict the rate of acceleration of an object's density versus buoyancy according to you using the formulas that we actually use gravity as part of that
Because
formula? How is it that
falling through that medium? You observe it falling through that medium and you measured it, and then you back engineered your formula according to that, which works.
Using
We don't
what?
need to reinvent the whole formulas just because we know it to be.
You don't know the formulas. You don't understand the formulas. You just admitted to
The
that.
same formulas. I don't know what you're talking about reinventing.
Yeah. See, but you notice that we were able to give you the formulas and explain them to you. That's the key part. Anybody can memorize formulas. Being able to explain them. But Ross, I want you to understand something. You have yet to explain anything that made any sense to anybody because you're making shit up. You honest to God are just pulling stuff out of your ass, going here, and nobody's buying it. Oh no, it is true, my friend. You're a nice guy. You really are, and I'm not trying to be dismissive of you.
Somebody asked me once,
but you're making shit up.
What is the explanation for gravity? And so I explained the explanation for gravity is you're in the medium of the density of air, and that's the rate at which it falls. If you remove the air, you remove all the air resistance, even the feather falls the same.
But how does it explain
interacting
acceleration?
with subatomic particles?
What about acceleration? Why does it not fall at the same rate? Why does it
because
increase in speed?
Because it's a larger mass and air gives very little
okay, you know what? And this is a great time for me to mention the third video that I linked in the internal chat, because you have a bowling ball and a feather with no air resistance falling at the same rate.
Exactly.
So the density, it doesn't matter, right?
A medium of zero density. Because air has some density, the feather has resistance, so it falls slower than the bowling ball. You remove the air, they fall the same rate.
Why is it the case? Why is it that you can use a metric tensor equation, which is for general relativity? Why can these people that are smart use these equations to model exactly where something's going to land, given these certain conditions? Why is it that the formulas they use? Why is it the math they use predictive of what we would expect if it is the case that space-time is curving and something is following the natural geodesic path from 2 points, from one point to another point?
I can tell you for a fact that when I was doing physics and a class,
you never did physics. Don't go there. You've never done physics, man. I'm never going to believe.
Every single one.
I will believe Jesus will come back tomorrow before I believe that you took a physics.
Ross, I don't think
it's all done on a non-moving
claim from you, Steve.
flat Earth. They're all
I'm sorry, Russ. Right?
Down on that. So that's why
Ross. I need to go because it's 5:30 in the morning. But can I just disprove one of Ross's points before I go?
Yes.
He constantly says that the elevation won't allow us to see further over a ball. Well, I've literally just done the math for it, and the difference between someone who's 5'7" and 6'2", which is about that much elevation, will actually increase what you can see by 1.05 miles. That's 0.15 miles. So
alpha arctan g 1 over g r squared. I don't know.
No, this is the equation to figure out for the horizon. Where based on the observer height, how far away the horizon should be.
Right. This is why you can go on. This is why you can see a sunset go down and then go to the top of a building and see it do it again.
Yeah. But he's saying that you cannot see further over a ball because you go up in elevation. But yes, you can. Just by 5 inches will give you an extra 0.15 of a mile that you can see.
And the reason that makes sense
on the reality of a flat Earth.
Hang on. The reason for that makes sense because if you think about it, the distance that you're claiming that you're getting further away from the sun is negligible when the sun is 93 million miles away, first of all. But you can actually see, and I think Red showed this graphic. Unfortunately, it wasn't a great graphic. But you can see the point at which a certain height, kind of the line of your horizon line, will intersect with the horizon. You can only see so far. Okay. Now, as the higher you go, that line skews this way. Meaning the point that it actually is tangential of hitting the earth. Do you know what a tangent means? A tangent line?
Yeah, but if you're going
I don't think you
perpendicular,
do. But
if you're
I
going
don't know what
perpendicular
tangent
by
is.
going up, you know, you
but
like
that,
you would.
but hang on, that tangent point.
You're going perpendicular. You're actually going further away from your tangent point, not further
It
towards
makes
it.
no difference that you're going further away. You're going vertical. You have an X and Y axis, horizontal and vertical components.
Going away.
Okay. Since I am increasing my Y axis, the tangent point on that sphere has to go down further. It has no choice, because if I have this much distance, if I can only see this far and I'm going further and further and further, it has to go further out.
We'll do it to a point. I agree with you.
Okay,
But
then
yes,
across a flat surface.
Stop at a certain
here's the
point.
thing. It will do it to a point, and that point is when you have 50% of that sphere visible to you.
which is your maximum. Is it not? I mean, how are you going to get more
Yes.
than that? So
Yeah.
No one
Yeah,
can see
sorry.
that far.
Go ahead, Jim.
Like saying we can see
So
4,000 miles or something.
so most people who understand science know that as you increase in altitude, that your density decreases. Do you believe that? Or
Air
do you believe,
density.
or do
Air
you believe
pressure.
that density maintains regardless of altitude? and I have a follow up.
All right.
Density of what, sorry?
Does density change according to your altitude is what he's asking.
What, the density of your body?
Anything.
Of anything, of a bowling ball.
Do you become lighter?
No, that's not what his
No,
question
no,
is. He's not asking you weight.
Density remains constant. Why would it change just because you've changed elevation?
Okay. So if you believe that it is since it's not linear but radial, how do we in order for an object to fall into an increase in speed, you would have to have another force playing on it besides just buoyancy and density in order for it to increase in speed?
Well, because we know that the air itself creates less pressure. So as it's higher up, it's going to fall faster through less dense air and gain a certain amount of acceleration until it reaches a terminal velocity point, in which case it stops accelerating, therefore negating the whole equation of gravity in the first place.
How does that negate gravity? It's still falling. How does it negate it?
Just explain gravity.
What does that even
the
mean?
formula of gravity.
And
It's
Ross,
still
you
falling
keep
because
saying
it's
about
still
this
falling
path
through
of
the
least
same
resistance. Ross, you keep saying about the path of least resistance that it will take. If something's going to take the path of least resistance, then it's going to go up because the path of least resistance will be through less density.
Yeah, that makes exactly. That makes
balloon,
it's
you're
good
right.
point.
Or if it's a hot air balloon.
Yes, I am right. Thank you very much.
But
End of
it's
discussion.
more dense than the air,
House
so
over.
of course it's going to fall through the air through the path of least resistance.
But you're missing his whole point on that.
I know exactly what he's trying to say, and he's just wrong. It's
You're
ridiculous.
saying
No,
How is he wrong?
path of
here's the
resistance
Okay,
less
okay.
than medium, which is up.
You have to be more buoyant than the air to go up.
Okay, look,
The mass
buoyant-
is
yes,
less
and the
buoyant than the air.
and the
Buoyancy-
buoyant
buoyancy-
equations require gravity.
Do you realize that what's funny is that Jungle Jargon actually isn't a flat earther. So the person I think that is the most confused in physics that I've ever met in my entire life, Jungle Jargon, understands this better than you do right now, Flat Earth Jesus. That's an accomplishment. I got to tell you, it really actually is.
All right, I've got to go. I just want to say I wish you all Merry Christmas. But more than that, Flat Earth Jesus, I wish that for once you will just listen to somebody and take in what's being told to you, because at this point you are just being willfully ignorant. And we can't help you if you are just no.
I am
You are being
negating it
you
with
refuse
logic.
to listen to anything that is told to you and just go nah because giants or something. All right, you need to stop being such an infantile little idiot and listen to what you are told. Just for once in your life, actually take something in and pay attention to what you're being told, because right now you are being stupid on purpose and it's annoying. All right, Merry Christmas,
Merry
but
Christmas.
stop being such an idiot.
Your
Roscoe,
interpretation
did
of
you
it, but
just-
you obviously
Roscoe,
don't
hold
understand reality.
Roscoe,
But see, hang on. You say it'll be confrontational, but then you assume that we don't understand reality. I will promise you, everybody in here probably has a better conception of reality than.
I've explained
you
it,
do.
though, multiple
let's get back to
Me?
reality and triangles for a moment. I've had this sitting here ready and waiting since the whole triangle thing came up. So In your case, being down in Australia, where the Southern Crux points to for Sigma Octantis, which is the star closest to the southern celestial pole, would you agree that that is a common reference point for everyone in the southern hemisphere?
Well, it's not so easy to say that.
It's a simple yes or no. Is it a single? Is it a common reference point for navigation by the stars when you are south of the equator?
No, because you can't even see it with a telescope. So for one thing, then it doesn't exist.
What do you mean you can't see with a telescope?
You can see the Southern Cross. That's what we can see with the naked eye. We cannot see Sigma Octantis. I've never seen it in my life. I go out looking at the stars all the time.
Why have I been to Perth and Sydney and have seen them both myself?
I think it's like a magnitude. Is it like a magnitude 3 star? And I'm guessing here. It's totally.
I don't buy it. I explained in the video show.
Somebody look it up. What the magnitude of Sigma Octantis is, because I'm pretty sure.
Yeah, you're right. I've never met this guy before. It's my first time to hang out with him, literally, and we just collaborated on this. Yeah.
Yeah. Well, I believe all the stars go around Polaris in one body, even in the sun.
All right.
I believe that the entire scientific community believes you're full of shit.
Well, hang on. I can work with that with this because I actually modeled it initially off of Polaris. It's just it works on both sides of the equator if you're actually intellectually honest. But let's just stick with Polaris for now. So.
Yeah. Okay, it's 5.7 magnitude. Okay, but anything under the threshold of 6, you can see with the naked eye pretty easily.
Yeah,
or at least decently clear conditions. So it's still visible.
You can see with a telescope easily.
Yeah.
Oh yeah.
So apparently not. So here we go. I'm just showing a little snippet of something that I created about 2 years ago, where this is on a flat plane, where I have the angles meeting the same latitude as the observation of the celestial pole. So if you notice at 90, it's straight up. At 70, we have a 70-degree angle. At 45, we have a 45-degree angle. At 20, we have a 20-degree angle. Notice how from this, none of these motherfuckers match up to the same point.
Yeah, because you're trying to put perspective.
And now go over here. Now, when we do that from a curved surface of a sphere with a known radius of 4,000 kilometers, wow, all those lines all of a sudden start to go parallel.
They're still going to different points though, aren't they?
No, they're actually going to the same motherfucking point, a butt-ton distance away.
Yeah, all the lines are parallel. They're parallel lines.
It's like sunlight would be. This would be like sun rays hitting the earth. This is why the experiment that Eratosthenes did with the sticks would work, because lines are parallel, and as you go further down towards the equator, it's going to have a different shadow cast.
Exactly, yeah. And since the sun rotates around the South Pole and not the North Pole, then the firmament would have to be located over the South Pole and not the North Pole, the way that you believe it is.
The sun goes around the equator constantly. It's by moving up, it appears
what does the equator
north. The equator is like the center of the known flat Earth. That's the path that the sun takes. That's why we have 2 equinoxes based on the equator, because as it's coming back down again, it passes over. The sun analemma proves that that's how it works. When it's up in the north,
how does that prove
that? The smaller side of the figure 8. When it comes down south, it takes the bigger side of the 8, and it crosses the equator twice for the equinoxes. It's moving up for the northern summer.
Have you heard yourself?
Perfect sense.
Argument?
I don't think
it's multiple times, and I've yet to have somebody actually try and debunk it.
But the main problem, and I don't know who it was that pointed this out before in the video, that they did an exceptionally good job, and I'm sorry, somebody could remind me, but they demonstrated that when the sun is at the Tropic of Cancer and the sun is at the Tropic of Capricorn, it'll always set in the same place still.
No, because when it's further away, if you're lying on your back,
but it doesn't.
Think about it. If you're lying on your back and you have a friend with
at the equator, it's still fall.
Yeah, somebody's got a ball on a string.
That's in that same place.
You're laying on your back, looking up at it. Now, if that person went up in a crane, that ball is going to appear to make a smaller and smaller circle as it gets more distant. But as it comes back down again, it'll appear to go in a bigger and bigger circle. That's what we're doing. We're always looking up at the bottom of stuff. We're trying to think, we're not thinking of it the right way when we're not thinking that we're looking up at the bottom of stuff. We're looking up at the bottom from down far below. This is the whole thing that most people don't get with flat Earth, because I think we're so big.
Most people don't get anything with flat Earth because it's absolutely crap.
And the farther south you go, the less you'll see from the horizon when you're facing north.
Depending on the time of year.
No, the further south that you go, the less you will see.
Of like the northern stars, for example, or north buildings, north anything. Yeah, that's right. Everything with distance.
Polaris in particular.
Sorry.
Are you talking about Polaris in particular?
Well, that's a good example because it's too far into the north. We can't see it beyond the equator, except for maybe this one place called Mount Kilimanjaro, because it's sufficiently high enough to be able to see far enough distance. You need to be high to see distance. We're down below on the ground. That's how it works. When you're looking up at something, as it gets further away, it'll appear to go further and further north into a smaller and smaller circle. As it comes nearer, it'll appear to go south, which is what the sun is doing for its part. But Polaris doesn't. It stays in the north.
How far away is Polaris?
I have no idea. It's right above the North Pole. I know that much.
Wait a second. Did you say the sun stays in the north? Is that what you said? I want to make sure I didn't mishear you.
Sun sets in the north.
Okay, so if you look out your window tomorrow, where's the sun going to rise?
Well, here it's just reached the most southern point, and so it's going to start heading back towards north now after December 22nd.
No, I mean, is the sun going to rise, say, south of east?
Yes.
Okay, you plot that on a map, on a flat Earth map, and we'll all enjoy that. You don't have to do it now. Just do it on
the map. Is giving you a 2D view of it when we're looking at it from the bottom up in the 3D reality. So as it gets further and further away, it'll appear to go further and further north. That's just how it works.
Yes.
No, you keep asserting
how
that's
can
how
it
it works.
rise or set in the south?
But the problem is that's not how any of this. None of this works the way you think
it is. If you stop and think about it.
Okay. Why do you? Hang on. I really want to address this. Why do you think that none of us have stopped and thought about this? We've all been somewhat educated in these topics to the point we've gone and learned about it. No. I mean this very sincerely. Why are you dismissive of us when we've taken the time to learn it? You have not learned anything about these things. I've asked you numerous questions. You got them all wrong. You don't know the basics.
You believe what you're told because you believe we live on a tilted ball spinning at 23.
Okay, so you're not going to address what I just asked you. You're going to change it to something else.
No, hold on.
Do you see how dismissive you are when it comes to that?
I'm trying to tell you the seasons are created by the reality of the sun getting further away and coming nearer. Even in heliocentrism, they say the sun is furthest from us until June 22nd.
But you can't show the physics and you can't show the math, right? Okay.
Hold on. So you just said that we believe this. Why are we, or that we taught this? Who teaches us this?
Why? Because the big agenda was to make everything appear to go around the sun because it's sun worship.
I didn't say why. No, you are answering a wrong question because I didn't say why. I said, who is teaching us this?
Who? Well, who do you think runs the world? It was the Jesuits, the Vatican. They're the ones who decided what we learn in all the universities. They're the ones who decide
they're not.
They tell us what they want us to know, and we believe what we're told. We think we're educated for learning
I think you broke Kyle.
Hang on.
Kyle is going, what?
Hang on.
I've been working on scheduling this entire time while y'all are doing y'all.
Oh, you look like he broke you on that one.
Wait, I would just like to point out to Ross, you just said that the organization responsible for all of the knowledge that is being taught in schools today comes from the same organization that when the rings of Saturn were first observed, tried to justify it as Jesus's ascended foreskin.
I haven't heard that one before, but it wouldn't surprise me what they try and tell us.
Somebody had actually written in the live chat in Hebrew, I cut off my own foreskin and gave it to my dog in Hebrew for some reason. That was interesting.
What the fuck is that?
I translated it.
Because they said they wanted to make it look as though the Earth goes around the sun. They wanted the sun.
No.
Because Lucifer worship is their god, and they want us to believe we're going around their gods through the 12 disciples of the Zodiac.
Oh my
13,
God!
It's 13 Zodiac.
If the Vatican was the one who was behind all of this, they would do anything and everything possible for us to understand that the Earth is flat because of the fact that
Wait.
they are religious people who would.
No, not at all.
Wait, no. I have a better question. If all of this information and all of this knowledge that we are pulling from now, that we have built everything that you are currently using to be a part of this conversation right now is based upon, was from the Vatican and from the Catholic Church, why is it that Copernicus had to wait until his deathbed to release most of his work for fear of excommunication?
It's the other way around. They didn't release it until 2 years after his death so that they could modify it to suit
They
their
weren't
purpose.
the ones
He
to
didn't want to
fucking
release it. He
release
said
it.
it doesn't work. He tried to fight
Yeah,
it.
they were actually very much against that. But by the way,
He
you said
released
there's,
his name afterwards. That's why all of history is a lie.
you
Everything
said there
we're
was
told is a
you
lie.
said there was 12 signs of the zodiac. Let me correct you. There was actually 13. There's one constellation called a Fucus. That is the 13th constellation. You can go look this
I'm a
up.
focus.
Yeah, he might be a Fucus. Well,
Well,
I bet you're a Fucus.
In common astrology, it's all divided in 12.
These-
Same as
Oh,
what we've got 12
well,
hours in a
I'm
day.
telling you right now, you can go look this shit up. Everything I try to say, I do have people validate. They have things like Google. Like I got the magnitude of Sigma Octantis wrong. I haven't looked at it in ages. It's 5 point something, but I said it was 3. So they corrected me on that because they can check that in real time. Anybody can go check this, right? That
Yes, but it's
13th
always
zodiac
been
is
the
a
12
Fucus.
houses of the zodiac. I don't care that they've changed it now and try to bamboozle us with more science now to try and get people away from true knowledge, but it's always been the
Astrology is true. Wait, astrology is true
That's
knowledge.
astrology.
Wait,
faithful disciple. Never
astrology is true knowledge. I want to get this on record.
Astrology is true knowledge, but mathematics is not.
Yeah.
Got it.
Well, it's all based on astrology. That's
Oh,
how it all-
really?
No, it's not.
Mathematics
But
is
it all
based on
goes
astrology.
around the earth, not around the sun.
Which
so
which
don't
part of the
go around
zodiac?
the sun.
Which part of the zodiac do you get your understanding of buoyancy and density?
That was-
Was it
Well, I think we've had enough, haven't we?
Wait.
Dipshittus, what's the other one?
We have constellations in the sky which we observe all year round, and that is what astrology is based on. We're born when the sun is in a particular sign, and that's what we say is the one that governs over our birth month at
Why?
the time.
Why does it do that?
Why? Because that's where the sun was at the time you were
But
born.
why? What influences
The vibration.
But,
from
but
the
I'm-
cosmos.
the
I'm outta
vibration
here.
of the sun. So because the
I love
sun's
you all.
position, the
And
vibration.
the stars are the ones that are watching over us. They're the angels watching over us. They're the fixed watchers. The sun is the powerhouse of
Good luck.
the
What
sun
are
of
comets
God,
then?
giving all the life. And wherever the sun is at the time of your birth, that's your sun sign, and it changes once a month.
Russell, it's nice to meet you
stars
tonight.
are- fuck.
I'm heading I'm heading out, but it was nice to
Yeah, we got about 10 more minutes, and I'm going to wrap this up.
Wait,
Oh,
so
you-
if stars are angels and the sun is, I don't even know. What are comets?
Demons, devils.
So,
Comets.
yes, what are comets is the question.
I would say they're another type of wandering star, wandering angel.
What?
Some
Oh,
messenger
so
angel.
wait,
The
so
tracks-
the angels are fixed, but they also move about.
It depends. The wandering stars move. They're the planets, so-called planets. They're the wandering stars.
Do you realize there was a
Constellation.
comet?
So, Earth-
There was a
Earth
comet
is
last week, Comet 46P, I believe it was called. I even asked
We have
Kyle, I said,
Shannon. I got some great pictures.
did you? Okay, well, because I messaged Kyle and I said, "Hey, dude, it's rainy here." It was raining here, I found out, but I messaged him and he's like, "Oh, it's overcast here." But I was hoping that he could go check it out because he has much clearer conditions. But I have not. I didn't see that one, but I have seen other comments. I've seen Hail Bob.
Steve, I'll send it when I can.
Yeah, and I appreciate it. I like to see it. I mean, did you get the green glow out of it, or
The pictures I took, I think they're mainly black and white, but
Okay.
I'll see what I have.
cool? But these are not angels. Dude, I'm telling you, they're actually just dirty snowballs. Okay, we've landed on
So
one.
maybe
Got
that's
pictures from them.
what they want you to believe, because it takes away
No,
from the
this is
sacredness of
observable.
the divinity of the place we live upon. That the
I mean,
divine Mother
with a
Earth.
good enough telescope, you can see the. I mean, I've done this myself. You can see the moons orbit around Jupiter. You can see Saturn's rings. You can see. They have surfaces, for God's sake, which rotate.
Here is the absolute kicker. you don't even need a telescope for Jupiter and its moons. The very first time I met Red was for an ISS transit. And the way we helped sight in and focus his P900 at the time was to locate Jupiter and zoom in on it and get the clarity right. And guess what? We saw the cloud bands, not in hyper detail, but you could see the striations of color. And we were also able to see the 4 largest moons orbiting it.
Fun fact.
With a fucking camera.
Ross, fun fact, if Jupiter didn't reflect the amount of sunlight it did, you actually could, in theory, in a clear condition, see Europa, Ganymede, Castillo, and Ganymede, Europa,
Io.
Castillo, and Io with the naked eye, believe it or not. But unfortunately, it gets occulted, or not called, it gets the fact that the Jupiter's so bright compared to them, it just because of exposure, if you can use a camera.
Yeah, it's the same reason you
maybe
can't see the stars around the moon.
Yeah, so you can't see them. Okay.
But why can't there be another explanation for them? Why can't they be much closer? Why can't they be orbs? We see orbs in photographs here
We've
on
been
Earth.
to them.
Well, and here's
Oh,
the
no,
here's,
Ross,
here's
no.
the great thing.
Hold
What
on,
are they?
hold on,
No,
hold on, hold on,
Ross,
hold on.
We have to
These
entertain an
orbs
idea
that
before you
we-
dismiss it.
No, listen,
Go ahead.
Roscoe. These orbs that we see in photographs
It's
are
dust.
usually, and this has been
Yeah.
found out to be dust.
Yeah, it's
This
dust.
is dust that has gotten too close to the camera lens.
What happens is, especially what's called a charge couple device, which is very cheap cameras. Okay. And the cheaper the camera, the cheaper charge couple device it has. And some of them don't have very high sensors, very good sensors. And some of them don't even have sensors for certain colors. They
Must be
extract-
special dust in the Philippines then. because
Hang
I've
on,
got
let me explain this to
multiple
people.
pictures in the
It can
Philippines
also be
of all-
moisture.
Let me
and
explain
I've
this
got
to people.
0 of them in
So if
Australia.
you hang on, Ross. So if you have conditions where you have generally with high humidity, high dust, and other things, what happens is when you have a flash, that'll flash off these dust particles or humidity or whatever's in the air, and that causes a reflection of light. And that the fact that the distance from the camera
angel.
to that particle, right? If it's a raindrop
I
or
know
whatever
you're
or
saying,
something,
They're not always done with a flash.
yeah,
Ross, it's not angels though. I mean, ultimately, it's just not angels. It's shit.
It's potential. It's potentially departed souls.
no, it's not.
No, it's not. It's not even potentially.
Even dude, you talking to the agnostic in the goddamn room, and I'm telling you, no, it's not. I take a stand on that. It is,
Dude, he's the Pope. He's
Okay,
got
we've got to end this before we.
Oh, you gotta end it.
This is a good time to wrap it up.
Yeah, I agree.
Dust angels is a good thing to end on.
Well, there is one thing I would like to correct
Sure.
because he did claim that it's like, oh, well, why can't they be closer than what they say they are? Why? Because we have directly measured to the majority of them, and they are those distances. Yes, you are talking to some.
Did you use?
I could be 6'11", but I'm not. It's just the way it is.
Here's the thing: a way you can measure a distance is by time at a known velocity. Guess what? Radio transmissions go at a known velocity. You time the reflection back from an object, you know the distance. We've done it to the moon, we've done it to Venus, we've done it to Mercury, we've done it to Mars.
That's
We also
exactly.
studied that.
That waves travel through the medium that they're in, and so we know that air gets thinner.
I got
Alright.
I got to end this now, but I have a question.
All right, I gotta say,
I got a question for Kyle. So
So
hang on, Kyle. We have a shit ton of super chats. Probably too long to even read now.
Oh no, I do need to read those. I said
Okay.
that I would, and I'm gonna read those.
All
Real
right,
quick.
it's up
You guys
to
can
you.
go if you want to.
There's so many of them.
you don't have to stick around.
You're gonna have to do them really kind of.
Yeah.
So we have 2 videos now. Where
Yeah, actually, we're gonna do what Red's do. We're gonna take a page out of Red's book. I'm gonna go around and let you guys say what you gotta say, and then get the fuck out. And then me and Steve will stay here and read these.
Okay. And get 'em out.
I know that it'll spark more debates, and we just
Yeah.
don't have time for that. So
I agree.
where's my wall of people at? Ross, so the guest will let you go first. Say whatever you need to say to wrap up, and then we'll say goodnight, and then we'll go to Jared.
No worries. Well, as I was just trying to explain, radio waves require a medium through which they propagate. Ordinarily, we're used to them going through the air, but we know that air gets less and less dense further up, less air pressure. So therefore, if you're going to be shooting them up really, really high, they're going to give the impression of going a much further distance and coming back much quicker, because we're trying to measure them at the density that we know they normally propagate through, which is basically sea level. So you're getting false readings from not understanding the way you're actually measuring something. So I'll just think I'll leave it at that. It's been great chatting. I enjoyed it.
Yeah, we
have you
appreciate you
back.
coming on. Thank you, buddy.
Yeah, we'll have you back.
Yeah, I mean, I got to admit, I disagree with you on
You
everything,
just-
and I do think you're mental in some ways, and I don't mean that derogatory, but I like you. I mean,
I don't think you're mental. I
you're a
think
decent chap.
I don't think you're mental.
Sure,
I
I
think
am.
you're batshit. If you're talking about all the orbs being angels, you're batshit. But you're personable, and that's what I like.
That shit. He's just got a different view. Goodbye, Flat Earth Jesus.
In the
No,
colloquial term.
Thank you.
Batshit.
David McGinnis. Okay, bye, David McGinnis. Hillel.
Hillel Finder, yeah, my boy Hillel.
Oh, Steve, please. I'm
You know
blushing.
You know I love
But
you.
I just want to say the ability to imagine reality in a different way does not make it so.
Okay. Frustrated atheist.
Yeah, so there's only two things that I want to leave off on. The first one is that I find it amazing that we still have people who believe that the Earth is flat when we do have evidence of and actual visuals of a planet being formed, and that it is forming into a globular shape. And then the second piece is the fact that I find it's incredibly amazing that the lower end of math that you go, as far as when you're, learning 2 + 2 = 4 and all that good stuff, that all that math is correct. But the very second the math goes towards being taught to pretty much show that the Earth is a globe, all of a sudden it's all incredibly false.
Okay. Goodbye, frustrated.
See you later.
Oh, my turn now?
Sure.
Mhm.
Yep. So I find it completely hilarious that he tried to tell someone who specialized in radio communications and radar for the U.S. military that he has no clue how those signals actually propagate through the atmosphere and how an atmosphere is required. Here's a hint. It's not. By the way, I'm going to go ahead and share these two links one last time.
And FYI, by the way, you may not know, I got for my eSWAS, you obviously know this. I had to learn about the 55 Bravo radar system and a lot of that same stuff. So, for them to just say by fiat, we have no idea about radars is bizarre.
Oh, yeah. Especially seeing as how radar fundamentals is taught in my A school. And radar is what was used to measure the distance to the moon before the retro reflectors were put up there. We also used it to measure to all sorts of other bodies. It's just hilarious and painful. But if you really want to piss off a flat earther, go ahead, enter my raffle to win the majestic jacket of Flurfer Butthurt and fund science at an elementary school level. With that, I'm out. Thank you for having me. I will see
Jared.
you
You're
guys
awesome.
all next time.
We
Have
didn't
a
go to the moon,
good,
by the way,
Christmas, man.
Remember, we didn't go to the moon.
Don't even get me started, Kyle.
Jim, I hate to do this, but I'll see you in a few anyway. So
Man, I appreciate you guys having me on. Physics and everything is not my strong point, but I do understand how how the different forces and the different theories play on each other, and how things work in relation to each other, and they work in sync with each other, and they are consistent, they are verifiable, they are repeatable, and they don't depend on loose conflation of terms like density and buoyancy. And I just want to take him like a little rubber duck and see how buoyant he is, just hold him under for a little while. But
That sounds like a physical threat.
Yeah.
No, like a rubber duck, like means like take a bath with him. Wait.
wait. Rubber duck. Oh, okay, I get it now. All right.
Yeah. What is? Oh,
that makes sense.
Ooh, okay. Yep.
Goodbye, Jim.
On that note, y'all have a good night.
Okay.
I love Jim.
Let's see
well, you love
here.
him in a different way, but whatever.
Let's see here. Okay. Caleb says that Steve is a big nerd. Antonio Auroras, if a flat earther falls in the woods, does his buoyancy make a sound? No, due to dropity. Attila the One says, "Go get him, fight the flat Earth. Geology proves a sphere. Debate me, you cowardly fluffers. God created me as the scourge of your morally bankrupt movement." He then also says, "Why don't items drop?" I've already read that. Drop sideways. Donate to my friend. Fight the flat Earth, or I will come find you. House always says, "Turtles are so 2018. Everyone that's ready for 2019 knows it's
Cephalopods.
cephalopods all the way down." Yeah. Orlor says, "I wonder if FEJ has ever seen the ice wall. If he can explain the southern celestial pole, being an Aussie." I think we read that one too. I propose a new show. Are flat earthers smarter than a fifth grader? From Orlor.
No.
Apothic New Zealand says, "Reds, you are a fucking badass." Yeah, tonight's Reds was the best that I've seen him since I've been doing this. So good job, Reds. Brian Peck says, "Why are you guys hosting an actual insane person?" If you think that is if he thought he was insane, then he has not followed this show very closely.
There's much worse than him.
Much worse.
Much.
I blame Steve for this, just saying, from Athena, goddess of wisdom and warfare. I do too. Amanda Garcia says, "How does light work if relativity?" And we read that one. Hello, sweetie. As an Australian, I am so sorry. Orlor says, "Rez needs to put on a sailor's cap and smoke a pipe in order for FEJ to believe him." There's a joke there. What is it? Sailor's cap and
like
a pipe.
Popeye.
There's a joke there. Somebody figure out what that joke is. As a Canadian, I'm sorry, says Antonio Aurorius. Yog Soloff says, "This has convinced me that flat Earth is mind cancer." Houseoy says, "I think FEJ's main problem is that his beard is actually pubes, so his chin balls has taken over his vocal cords. Thinking it's his rear sphincter. That's why he's ejaculating so much still at the moment."
Damn, Houseoy. That's
good Lord.
Damn, buddy.
That's a fiery.
Houseoy must have been a bad
God.
mood today, but that was awesome.
for 100 knocks. Bodie McBoatface says, "This guy's been smoking too much Mullen Madness." Frito says, "An idle brain is the devil's workshop." H.E. Bond, Merry Christmas to Non-Sequitur and everyone. Merry Christmas to you as well. Schrodinger's cat says, "I went through the Suez Canal many times. It's not flat until the one parallel lines were never crossed, no matter how far." Akatsuki gang, make it stop, please. I saw that a lot in tonight's chat, and I don't know if they're aware, and just I feel it's our duty to let them know that if it's that bad, y'all, if it's that bad, there is you don't have to wait on Steve or I to do it for you. There's a little button in the top corner of whatever you're watching us with, and it's got a little X in it. And if you click that little X, it will stop for you, and there's no need to draw attention to Steve or I, just in case you didn't know. Since Fredo Sarabia says, "Do wheels disappear bottom up on a warm day?" Yeah, probably. DJ Moss, atmospheric lensing, perspective diffraction, etc. Bullshit. Jay Sullivan, Australian beer sucks. Mac HD, Aussie all word salad, no flat earth model. Mark Beiser, gotta admit, I can't think of one single rebuttal for one of flat earth Aussie's Jesus actual logical arguments. Oh wait, he hasn't made none. Jay Surveillance says, "ZZ Top doesn't know shit." I don't know. ZZ Top knows shit. ZZ Top knows shit.
I like ZZ Top.
I do too.
A lot, actually.
Josie Neurotic says, "I'd like a flat earther to explain how the interior of the earth works." Oh, we did that one too. Antonio Arroyo says, "We need to have a flat earth bingo game for these debates. Ask and ye shall receive. Beginning in January, you will have that actually. That's all I'm going to say right now, but that's in the works." Peter Miss Prime says, "The atmosphere sitting next to a vacuum argument is a straw man. Nobody says that the atmosphere sits right next to a vacuum. Please acknowledge this." Yeah, there's not like the atmosphere sitting next to a Dyson. We know that. Or a Hoover. It doesn't exist. Attila the One says, "Fiage, what would happen if you were in a vacuum standing on a car and jumped off the car? Obviously, you'd propel yourself forward and the car oppositely." Cario Genie C says, "I think this guy's beard grew into his brain." Jay Sullivan said, these super chats are vicious
tonight. Yeah.
Jay Sullivan 80 says, "Leftover pizza is the best pizza." On that, I agree 100%.
I like leftover pizza.
Renee Calusia says, "Eric Dubé, best globortionist on flat earth." What? Globortionist.
Somebody who kills globers. I don't know.
Okay, I want to draw attention to. Let me go ahead and read the rest of Renee's super chats first, then I'll draw attention to this. Flat Earth defends itself, unstoppable. Love is bombarding children's websites with flat Earth. Now, these words are sitting next to a Mensa avatar.
It's just sort of dichotomy.
Steve, let's take a second to pay respects to the irony that's there.
Yeah, well, I think it's meant to show the difference between somebody who's probably in Mensa and somebody who's clearly not.
Renee, we appreciate your super chats.
Thank you, Renee. We appreciate it, though. You can promote Flat Earth all you want for $2 a pop. We don't mind.
Sure. I have no problem reading that Flat Earth defends itself. It's unstoppable, because we all know that's absolutely true. I mean, 100% true. Citrito Cerebria says, how does combustion continue to work without oxygen? Mexican Wrath says, this guy just grabbed the laws of motion and threw them out the window one day. James Harvey, even brewers us math to make that beer you are making.
Yeah, I think it meant use math. Yeah.
Use. Okay. Yeah, that makes sense. I calculate ABV. Alchemist says, ask him what an object falling in a box will do. Jen Morgan, flat Jesus, you are silly and deluded fool. Grow up, use that brain for good, not stupid. AC Castillo, reason for a worldwide globe Earth conspiracy. James Freeman. Hello, everyone. James Freeman. He says, flat Earth Jesus, these guys are all idiots. I believe everything you say. Hit me up, man. We can get together and write letters to Santa after the show. The only problem is if you do that, flat Earth Jesus, you will be detained. I just want to let you know that. You will be detained. NZ Pure says, look out, I'm on a boat. Makes as much sense as flurf. And then Apophic New Zealand, I'm assuming, says, thank you for your service, boys. Let me just double check to make sure that's all.
I think James did get arrested the other day. I know a few people have gotten.
No, Patrick did.
Well, I know Patrick got arrested. I know News Now Houston got. He didn't get arrested, as in they took him away, but they cuffed him and put him in the back of a squad car, which to me is arrest.
That happens to him every weekend.
But I don't understand how they get away with that. They're like, oh, we're going to arrest you. Then we're going to find out who you are. And then we're just going to let you go on some technicality or something. It's like, it's such a bullshit game they play.
Most of them don't know themselves, though. That's they have to have a supervisor come in, and by then they're already handcuffed, and it's too late. But I
don't know. These people don't sue. I would sue everybody for.
It costs too much. That's the thing. Like it I'm sure they would if they could, but it costs too much to do that every time. Not Your Witness says, on behalf of all Australia, sorry, boys. Actually, you should apologize for those pigtails that you have on behalf of Australia, not Father of Jesus, Not Your Witness. Okay, anything else?
One more.
Oh.
Rez.
Go ahead.
Res instance. Sup, late as usual. Living in Australia sucks when so much of your favorite content comes from the United States. You know what? We have a surprise for you, actually.
We do.
Kyle wants to
we're gonna start doing a thing called Tea Time on. I'm going through. I got a bunch of. I asked on Twitter and I asked on YouTube, our community page, what days would everybody would be better. It was to our UK and our Australia, New Zealand, everybody on the other side of the pond, so to speak. And we're going to do a day show just for you guys so that you have something that you don't have to stay up till God knows when to watch these. Because we do kind of feel bad for that. And we do appreciate you guys sticking with us and watching. So we feel that it's the least we can do to I'm thinking it might be a Saturday. That's seemingly so far. That's the day that everybody's putting.
But he's from Australia. Australia's not that late. Perth would be 2:00. Sydney would be 5:00 right now, give or take, whatever it is.
Yeah, but I know that that's the only thing that's going to throw. Like when they say Saturday, I don't know if they mean their Saturday or our Saturday.
I had that mistake happen this recently with Dr. Opie. We messed up the dates because I was saying Wednesday, but that was actually would have been Thursday for him. So
because it would work out perfectly to be our Saturday, but it would be their Sunday. So I mean that would work out perfect. I know that when we do a show with Tim O'Neill and it's at 8:00 our time, it's at 10 a.m. his time the next day.
Mm-hmm.
So where we're at, so I mean that wouldn't be bad, but we'll figure it out, and that will be starting the first week in January, guys. So as soon as we go through this little break for a couple of days, it'll pick up that next week for the New Year's. And we got a couple of surprises for you guys for when we come back for New Year's. A new look and all kind of stuff. So we'll be hitting the new year hard. But if
Just the way you like it, right?
Oh, always. If you didn't know, we're trying to hit 20K before Christmas. That's our Christmas wish. We are so close. I mean, we are so close. We're less than 175 now away. So we can make this happen. And we appreciate you guys sharing out the link and everything that you do. And I'm going to shut up now and go to sleep. I'm going to eat the rest of my fried pickles, and then I'm passing out. So,
good night.
Yeah, let's end it that way.
All right. Yeah. Listen to that way. Good night.